In this video, we continue to discuss competition between species. There is a fixed point where both species persist. We'll investigate that fixed point in this video. However, we're going to elide a lot of detail here. In the last video, we didn't even find out what the fixed point was in terms of the constants of the system. We just called it xe, ye. And we'll continue that here, but our results are interesting. Let's write out the equation again, commenting as we go. So here's one species. The first term represents exponential growth. If we stopped writing here, we would be saying that there are unlimited resources. So there's no competition for resources. And the population growth depends only on the number of animals. The next term turns the growth logistic. There are no longer unlimited resources. The environment has a carrying capacity that species can't surpass. Thus, members of the same species are in competition for limited resources, and that limits the population. So this B1 term is a competition term. It represents intra-species competition, the fight these animals have with each other for limited resources. This last term is also a competition term. It represents extra-species competition. The competition between species X and species Y for limited resources. And likewise, in the other equation, B sub 2 and C sub 2 are competition terms. So these B sub 1 and B sub 2 terms represent intraspecies competition. To measure how important these terms are taken together, we'll multiply them together. If these terms are large, the product is large. If these terms are small, the product is small. And these C sub 1 and C sub 2 terms represent extra species competition. The competition between X and Y. Again, to measure how much this competition matters, we'll multiply them together. And now we can compare how important the interspecies competition is versus how important the extra species competition is. And we have the following result. If C1, C2 is less than B1, B2, the fixed point X sub E, Y sub E is asymptotically stable. And the two species can coexist near those population levels. So this inequality tells you that competition between the two species isn't actually happening at a significant level. The animals in this environment are competing more with different members of their same species than they are with members of a different species. If B sub 1, B sub 2 is less than C sub 1, C sub 2, the first point, the fixed point, X sub E, Y sub E is unstable. And the two species can't coexist. This inequality tells you that there is significant competition between the species. And One of these species is going to drive the other to extinction. In this video, we've stated a mathematical result about competition between species. We'll do a concrete example in the next video.